Good morning, students. In this video I am going to explain about subsequential limits and limit supremum, limit infimum, and I solve some problems based on these rules. Okay. First of all, tell me what is a limit of sequence? How can we find limit of sequence? Tell me. How can you find limit of a sequence? We find the limit of sequence at n tends to infinity. Let Sn is a function. Sn is a sequence. How can you find limit? At limit n tends to infinity, we find the limit of this Sn. Okay. Next. See. The first one is subsequential limit. Subsequential means we find the limit of subsequences. Okay. First we find the limit of subsequences. What is a sequence? Sequence is a nothing but function. What are the elements in sequence? The elements of range. The elements which is lies in range are called the elements of the sequence. What is subsequence? Subsequence is also a sequence. It's derived from a sequence by deleting some or no element. First we take a sequence. What is that sequence? Let Sn equals to 1, 2, 3 and so on is a sequence. Let Snk is a subsequence. I take some elements. What elements? Only even numbers. Okay. Then Snk is a subsequence of Sn. I take elements from Sn. So Sn is sequence. I take elements from Sn. I write a subsequence Snk. Okay. Okay. Is it clear? Tell me. Can we write how many subsequences for a sequence? Tell me how many subsequences we write for a sequence. See here. Here Sn is a sequence. What are the elements in this? 1, 2, 3 and so on. What are the subsequences? Possible subsequences, tell me. Let first Snk is a one subsequence. I write only even numbers. I take another subsequence Sni. I write only odd numbers. I take another subsequence Snj. I write only prime numbers. Another sequence Snl. I write only composite numbers. Another sequence SLM. I write only 4 multiples, means 4, 8, 16, like that. This means we can write so many subsequences for a sequence. How many subsequences we can write for a sequence? So many. See here. First one is subsequential limit. Subsequential limit means, see here. Let Sn is a subsequence. Let Sn is a sequence in R, real number sequence. Okay. Then any real number R plus infinity or minus infinity, that is the limit of some subsequence of Sn. If you find a limit for any sequence, we find the limit at n tends to infinity, 1 by n square, or limit n tends to infinity n square, or 1 by n plus 1, or n square plus n plus 1. What sequence we take, we find limit at only n tends to infinity. What is the possible values of limit? Either positive value or negative value, or a fraction, positive fraction or a negative fraction, any real number. Any real number we get as a limit, or we get only plus infinity or minus infinity. There are 3 possibilities are there. One is real number, either root value or log minus value, negative value, fraction value, decimals value, any other value. We call it as real number. Otherwise we get plus infinity or minus infinity. So 3 types of limits we exist. There are 3 types of limits exist. What are that? Any real number, or plus infinity or minus infinity. See here, Sn is a sequence. Okay. Then any real number plus infinity or minus infinity, that is the limit of some subsequences of Sn. Plus infinity, minus infinity, real number is the limit of not the sequence of Sn. Subsequences of Sn is called subsequential limit. First we write a sequence Sn. Then we write some subsequences. Sn1, Sn2, Sn3. and we find the limit of these subsequences. The set of all these subsequences limits are called subsequential limit. Okay, the limit of subsequences are called subsequential limit. If you write all these subsequential limits, as I said, we call it as set of subsequential limits. See here, one example is there. Here Sn equals to n square into minus 1 whole square. See here, what is the example? Sn equals to n square into minus 1 whole power not square n. Okay, what is the sequence here? Sn equals to n square into minus 1 whole power n. What are the elements of Sn? First we take 1, substitute 1 in n's place. What we get? 1 square into minus 1 whole power 1. This is n, not square, okay? What we get? Minus 1. Now we put n equals to 2. What we get? 2 square into minus 1 whole square, that is plus 1. Next we substitute n equals to 3. What we get? 3 square into minus 1 whole cube. Then what we get? Minus 1 whole cube is minus 3 square is 9, minus 9, like this. Okay, these are the elements of the sequences. Now I write subsequences of 1. Let subsequence of Sn are Sn1 and Sn2. Then I take only 2. See here, in Sn1 what I write? All negative elements is there one subsequence, and I take all positive values are another sequence. Okay, I write 2 subsequences of Sn. What are they? Sn1 and Sn2. In Sn1 I take only negative terms. In Sn2 I take only positive elements. Okay. Tell me, is Sn1 is decreasing or increasing? Minus 1, minus 9, minus 25, minus 49, like this. Is it decreasing or increasing function? Decreasing function. Okay, is it a decreasing function? Okay, what are the last value and so on means what is the ending value? Minus infinity. Therefore what is the limit of Sn1? Is minus infinity. Similarly in Sn2 what are the elements? 4, 16, 25 and so on, like this. Tell me, what are the elements here? Is it increasing or decreasing? Increasing. What is the maximum value? Is plus infinity. This is the limit of Sn2. The limit of subsequence Sn1 is minus infinity. The limit of subsequence Sn2 is plus infinity. Therefore, set of subsequential limits, we say it denoted by capital S. We denoted subsequential limits with capital S equals to, what are the limits here? Minus infinity and plus infinity. Okay, is it clear? First we take a sequence. What are the elements in this? We write. Next we write some subsequences and we find the limit of this subsequence. We get minus infinity and plus infinity. So I write these subsequential limits as a set. So it is called set of subsequential limits. We denoted set of subsequential limits with capital S. Next, note where Sn, Sn1, Sn2 are divergent sequences. Why? What is the meaning of convergent? If a sequence has limit, it is called convergent. If sequence has no limit, it is called divergent. If sequence has limit means the limit should be a real number, not plus infinity, not minus infinity. But here we have only plus infinity and minus infinity are the limits. So it is a divergent sequence. Next, limit supremum and limit infimum. In first video I explained about supremum and infimum. Let Sn equals to, what is the element? What are the elements here? 1, 2, 3, 4. Tell me, what is the lower bound? This one, this sequence. Lower bound is 1. What is the upper bound? Upper bound is 4. What is the meaning of lower bound? Lower bound means minimum value. That means it is infimum. What is the infimum of Sn? 1. And we call maximum value as supremum. What is the supremum of this sequence? Is 4. Infimum and supremum are minimum value and maximum value of the sequence. Okay. Now what we find here? Limit supremum and limit infimum. See here. Let Sn be any sequence of real numbers. Okay. Let capital S be the set of subsequential limits of Sn. Okay. What is the capital S means? Set of subsequential limits of Sn. Then this is the formula of limit supremum. See here, limit supremum of Sn equals to limit n, where we find limit, we always find limit at maximum value of small n. That means at n tends to infinity. Limit n tends to infinity. Supremum of Sn equals to, it's equals to what? Which value? Supremum of capital S. Capital S means set of subsequential limits. If you want to find the limit of supremum of given sequence, we can find from the supremum of set of subsequential limits. See here. What is the limit supremum of Sn here? Tell me. Limit supremum of Sn is equal to which value? Supremum of capital S. Limit supremum of Sn is equals to supremum of capital S. What is capital S here? Minus infinity comma plus infinity. Supremum means maximum value. What is the maximum value of S? Capital S. This is plus infinity. Okay, is it clear or not? If you want to find limit supremum of Sn, first we find supremum of capital S. First we find capital S. That means set of subsequential limits. Then we take supremum value. It is equals to the limit supremum of a given sequence. Next, what is limit infimum of Sn? Limit infimum of Sn is equals to infimum of capital S. See here, what is the infimum of capital S here? Minus infinity. So, limits infimum of Sn is limit infimum of this sequence is minus infinity. Okay. Next, from 1 means see here, where is 1? This is elements of Sn 1. Let this given sequence is 1. From 1, supremum of Sn equals to plus infinity, supremum of Sn equals to minus infinity. Only I wrote here only Sn, only for Sn, until this sequence. I write only supremum and infimum of this sequence. Supremum means maximum value. Maximum value means positive value. What are the positive values here? 4, 16, next 36, and so on, like this, plus infinity. What are the minimum value? Minimum value means decreasing. Minus 1, minus 9, minus 25, and so on, like this, minus infinity. What are the infimum and supremum of Sn is minus infinity and plus infinity. Okay, next. That implies I applied limit. Limit supremum of Sn equals to, what is the limit of a constant? Tell me. Limit n tends to infinity to limit of 2 at n tends to infinity is 2 only, since 2 is the constant. Okay, similarly here plus infinity is the constant. So what is the limit of supremum of Sn is plus infinity. Similarly, limit infimum of Sn is minus infinity. From 2, what is 2 here? See, subsequential limits S equals to 2. From 2, what is the infimum value? Minus infinity. What is the supremum value? Plus infinity. See here, from 2, supremum of capital S equals to plus infinity. Infimum of capital S equals to minus infinity. So, limit supremum of Sn is equals to supremum of S equals, and limit infimum of Sn is equals to infimum of S. This is the most important formulas. Next, there is a problem. See here. Consider the sequences defined as follows. What are the sequences? First one is an equals to minus 1 whole power n. B equals to 1 by n. Cn equals to n square, and dn equals to 6n plus 4 by 7n minus 3. There are 4 sequences. Then find what we have to find here. 5 points. We have to find 5 points. What are they? First one is we have to show the given sequence is monotone, has monotone subsequences. First we have to show these given sequences has the monotonic subsequence. Here we have 4 sequences AN, BN, CN, DN. What we have to find here? We have to show first one is each sequence has monotone subsequence. And second one is we have to find the subsequential limits of the given sequences and limit supremum, limit infimum. Fourth one is which of the sequence converges or diverges. From these 4 sequences, which sequence is convergence or which sequence is divergent. Okay. Fifth one is which sequence is boundedness. We have to find all these 5 points. Okay. First one is, see here, first problem. See, AN equals to minus 1 whole power n. What is the sequence here? AN equals to minus 1 whole power n. Okay, first I write the elements of AN. First put n equals to 1. What we get? Minus 1 whole power 1. That means minus 1. If you put n equals to 2, minus 1 whole square. That is plus 1. If you put n equals to 3, minus 1 whole cube. That means minus 1. If you put n equals to 4, plus 1. Like this. Minus 1 plus 1. Minus 1 plus 1 are the elements of the AN. Okay. First first point is what we have to find here? Monotone subsequence we write. I write 2 subsequences. What are the AN1? First subsequence is AN1. What are the elements here? I take only negative values. Minus 1, minus 1, minus 1. And I wrote another subsequence AN2. I took only positive values. Okay. In AN1, what are the elements here? Minus 1, minus 1, minus 1. All are same. Is this monotone sequence or not? That means AN1 has only one element, that is minus 1. Is it monotone sequence or not? Yes. The constant sequence is always a monotonic sequence. Similarly, AN2 is also a monotonic sequence. Okay. Similarly, AN2 is also a monotonic sequence. First point is completed. What is the second point? We have to find subsequential limits. So what is the second point? We have to find subsequential limits. See here. First subsequence is AN1. Limit n tends to infinity. AN1 equals to what? Minus 1. Constant function. This is constant function. Okay. AN1 is equal to what the elements here? Minus 1. It is constant function. So, the limit of constant function is the same constant. See here. Limit of AN1 equals to minus 1. Similarly, limit of AN2 equals to plus 1. Therefore, subsequential limits capital S equals to minus 1 comma plus 1. What are the subsequential limits here? Minus 1 comma plus 1. Okay, is it clear? Okay. Next, third one. Limit supremum of AN. What is the formula of limit supremum? Supremum of capital S. Limit supremum of a sequence is equals to limit supremum of capital S. What are the elements in capital S? Minus 1 comma plus 1. Then what is supremum? Maximum value is plus 1. Similarly, what is the value of limit infimum of AN? Limit infimum of AN is equals to limit infimum of capital S. That means minus 1 comma plus 1. What is the infimum? Means minimum value minus 1. Therefore, limit supremum of AN equals to plus 1. Limits infimum of AN equals to minus 1. What are the elements of the given sequence AN, not subsequence? The sequence AN elements are minus 1 plus 1, minus 1 plus 1, minus 1 plus 1, like this. It is a oscillating sequence. It is neither decreasing nor increasing. This is not increasing function. This is not a decreasing function. Oscillating function we call. So, therefore, what is the fourth point? AN is an oscillating sequence. And last one, what we have to show here? The sequence is bounded or not? Is the sequence bounded or not? Bounded means the sequence has lower bound and upper bound. That means infimum and supremum. What is the infimum here? Minus 1. What is the supremum here? Plus 1. Therefore, lower bound is minus 1, upper bound is plus 1. Therefore, AN is a bounded. Okay. Next. See here, the given sequence is minus 1 whole power n. First one is the sequence has monotone subsequence. Why? This is a constant sequence. So every constant sequence is monotone. So we write this is a monotone sequence. Next one is subsequential limit. First subsequence limit is -1 and second subsequence limit is +1. Therefore, capital S equals to what we wrote? -1 comma +1. Okay. Next, limit supremum of an. What is the formula of limit supremum of an? Limit supremum of capital S. What are the elements in capital S? -1 comma +1. Then supremum is +1. Then similarly, limit supremum of infimum of an equals to we get -1. Next, which of the sequence is it convergent or divergent? This is divergent since it has -1 +1 -1 6. This is oscillating sequence. So we write it divergence. Okay, next. Is this bounded sequence or not? Bounded. Why? It has lower bound and it has upper bound. So this is bounded sequence. First one is completed. What is the next sequence? Bn equals to 1 by n. First we find subsequence. Is it decreasing or increasing? Next, subsequential limits. Next, supremum, infimum. Next, the given sequence is convergence or divergence. Next, we check boundedness. Okay, remember. Next sum is Bn equals to 1 by n. First, I write the elements of Bn. Put n equals to 1, 2, 3. What we get? 1 by 1, 1 by 2, 1 by 3, 1 by 4, and so on. These are the elements of Bn. So, here I wrote a subsequence Bn1. I took only even numbers. See here 1 by 2, 1 by 4, 1 by 6 only. In denominator I take only even numbers. 1 by 2, 1 by 4, 1 by 6. These are the elements of subsequence. Then what's the function? Bn1 equals to, what is the sequence? Subsequence is 1 by 2n. This is monotonic decreasing subsequence. See here, what are the elements here? 1 by 2, 1 by 4, 1 by 6, 1 by 8, 1 by 10, like this. If denominator increases, automatically the value of the fraction decreases, okay? So, this is decreasing subsequence. Therefore, Bn has monotone subsequence. First point is completed. What is the second point? Subsequential limits. That means we find limit of subsequence. What is the subsequence here? Bn1 equals to 1 by 2n is the subsequence. Now we find the limit of the 1 by 2n. Where we find limit? At n tends to infinity. See here. Limit n tends to infinity. 1 by 2n equals to, we put infinity in n space. What we get? 1 by 2 into infinity means 1 by infinity. This is 0. What is the limit of this subsequence? 0. Therefore, the set of subsequent limits capital S equals to 0. Of course, we take another subsequence like only odd numbers 1, 1 by 3, 1 by 5. Here also we get the same limit 0. So, therefore, the set of subsequent limit is 0. Second point also completed. Third point is limit supremum of given sequence Bn and limit infimum of Bn. Limit supremum of Bn equals to limit infimum of Bn equals to 0 only. Why? We have only 0 in only one value, that is 0 in set of subsequent limits. That implies infimum is 0 and supremum is 0. So I write limit supremum of Bn equals to limit infimum of Bn equals to 0. Fourth one is that given equation converges or diverges? Bn converges to the real number 0. How? Convergence means if you want to check the given sequence is converges on R, what we find? Limit. What is the limit of Bn? Tell me. At n tends to infinity. Limit n tends to infinity 1 by n is equal to 1 by infinity. This equals to 0. So the given sequence is convergence. Next. Is the given sequence bounded or not? See here. We check Bn is bounded or not. Okay. What is the elements of Bn? 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5 and 6 law and so on. At the end, what we get? 1 by infinity. That means 0. So, From this, what is the highest value? 1 is the maximum value, that means upper bound. What is the least value? 0 is the smallest value, that is lower bound. Therefore, the sequence Bn has upper bound and lower bound. Therefore, Bn is bounded. Okay. Next sequence Cn equals to n square. First I write the elements of n square. What are the elements of n square? 1 square, 2 square, 3 square, 4 square and so on like this. That implies we get 1, 4, 9, 16. Is it increasing or decreasing? Increasing. Okay. First I write a subsequence Cn1. I took only odd numbers 1, 9, 25 and 49 like this. Now what is the sequence? What is the function of subsequence here? 2n minus 1 whole square. If you substitute n equals to 1, what we get? 2 into 1 minus 1 whole square. That means 1 square and 1. Okay. If you put n equals to 2, 2 into 2 minus 1 whole square. 2 2 ja 4 minus 1 and 3 square and 9. We put n equals to 3, 2 into 3 minus 1 whole square. 2 3 ja 6 minus 1 5. 5 square means 25. Okay. This is the function of the subsequence. It is also an increasing sequence. Therefore, it is a monotonic increasing subsequence. Next point. What is next point? We have to find subsequential limits. See here. Subsequential limits means you have to find the limit of subsequence. What is the subsequence here? 2n minus 1 whole square. Limit n tends to infinity. 2n minus 1 whole square equals to, we put infinity in n's place. 2 infinity minus 1 means infinity. Whole square means infinity, whole square and infinity. What is the limit of this subsequence? Infinity. See here. Limit n tends to infinity. 2n minus 1 whole square. I write infinity in n space. 2 infinity minus 1 whole square is equals to infinity. Therefore, limit set of subsequence limit capital S equals to what we get? Infinity. We have only one value, infinity. So, limit infimum also infinity, limit supremum also infinity. See here, if here we get only the limit 0. So, we write infimum and supremum is 0. Similarly, here also we write limit supremum of Cn. Limit infimum of Cn equals to infinity. Infinity means, is it convergent or divergent? If a sequence is convergent, it has only real number as limit. It has the limit in only real number. If limit is plus infinity or minus infinity, we call it as divergent. Okay. So, Cn is the divergent sequence. Last point, is it bounded or not? Okay. What are the elements of the given sequence? 1, 4, 9, 16 and so on. What is the last value? Plus infinity. That means no upper bound. It has no upper bound. In plus infinity means which value, how much value we can't say. So this sequence has no upper bound, only lower bound it has. Therefore it is unbounded. See here, from 1 lower bound is 1 and upper bound is infinity. So Cn is unbounded. Last one, this is the important sum. See here, what is the sequence given? Dn equals to 6n plus 4 by 7n minus 3. If you put 1, what we get? 6 into 1 plus 4 by 7 into 1 minus 3. That means 10 by 4. That means 5 by 2. It is the first element. What is the first element? 5 by 2 is the first element. What is the second element? Put n equals to 2. What we get? 6 2 is 12 plus 4. 16 by 7 2 is 12. 14 minus 3, 11. What is the third element? 3 6 is 18 plus 4, 22 by 3 7 is 21 minus 3, 18, like this and so on. How many numbers we have to write here? So many numbers. So we can't find upper bound and lower bound in this case. Okay. If in this sequence we can't find upper bound and lower bound by writing this type of numbers. So we don't write this type of elements here. See, we solve this in another model. We learn in this type of solution in sequences. Unit 1 sequences, we learned this type of solution. See here. I took dn plus 1. Now I find here dn plus 1 minus dn value. What is dn plus 1? We put n plus 1 in n's place, we get dn plus 1. See, 6 into, we put n plus 1 in n's place plus 4 by 7 into n plus 1 minus 3. This is the value of dn plus 1 minus dn means 6n plus 4 by 7n minus 3. Okay, dn plus 1 minus dn is equal to, dn plus 1 means we put n plus 1 in n's place in given equation, given sequence, and minus dn is we write given sequence same as. Okay. After simplifying, what we get here, 6n plus 1 plus 4 means 6 into n 6n, and 6 into 1 6 plus 4 10. And denominator 7 into n 7n, 7 into 1 7 minus 3, that means 4. So we get 6n plus 10 by 7n plus 4 minus this is same. Now we take LCM. What is the LCM? 7n plus 4 into 7n minus 3. So 6n plus 10 into 7n minus 3, 6 minus 6n plus 4 into 7n plus 4. After simplifying, what we get here? Minus 16 by 7n plus 4 into 7n minus 3. Minus, which value we have here? Negative value. That means less than 0. What is the value of dn plus 1 minus dn is less than 0. That implies dn plus 1 minus dn is less than 0. Now take dn in LHS. What we have here, dn plus 1, we take dn in LHS less than dn. Okay, dn plus 1 less than dn means dn plus 1 less than dn means what? First we put n equals to 1, what we get here? Put n, for n equals to 1, d2 less than d1. For n equals to 2, d3 less than d2. For n equals to 3, d4 less than d3. Combine all these terms. What we get? d4 less than d3 less than d2 less than d1 and so on. Now I write this reverse order. That means d1 greater than d2 greater than d3 greater than and so on. That means first value is greater value. Next one is d1 less than d2 means next one is smaller than d1, and d3 is smaller than d2, and d4 is smaller than d3. That means, is that sequence decreasing or increasing? Decreasing sequence. Is it clear? First, in this type of sequences we solve like this. Is it increasing, or for finding increasing sequence or decreasing sequence we use this method. What is that method? We find dn plus 1 minus dn value. What we get? Dn plus 1 minus dn. If dn plus 1 minus dn greater than 0, this is increasing sequence. What we get here? Minus less than 0, negative value we get. So I write minus in less than 0. I take minus dn in RHS, dn plus 1 less than dn. That means the first number is the greater than the second number, and second number is greater than the third number. That means the given sequence is decreasing sequence. First point completed. Next, what we have to find here? Limit. Where we find here in limit n tends to infinity, 6n plus 4 by 7n minus 3 equals to, I take n common, so I get 6 plus 4 by n and 7 minus 3 by 9, 3 by n. Now I put n equals to infinity, 6 plus 4 by infinity by 7 minus 3 by infinity. What is value of 4 by infinity? 0. Similarly 3 by infinity is also 0. So the limit of dn is 6 by 7. We find only one limit, so that what is the set of subsequential limits? 6 by 7 is the only one limit. So I write limit supremum of dn and limit infimum of dn is 6 by 7. If limit exists, then it is a convergent sequence. Is it real number or not? 6 by 7 is a real number, so it is convergence. Now we have to find the given sequence is bounded or not. That means we have to find lower bound and upper bound. Okay, is given sequence is increasing or decreasing? Decreasing sequence. That means first value is the upper bound and up to last value is the lower bound. Last value means where at n tends to infinity. What we get here? The last value. So what is the upper bound here? 6. See here, 6 by 7 is the upper bound. At n tends to infinity means decreasing sequence. At n tends to infinity means last value is the lower bound. What we get here? 5 by 2 is the lower bound of the given sequence. Okay, is it clear? Okay. Next important point, students. See here, one important point is there. If Sn converges to a real number S. Sn converges to a real number S. What is the definition of convergence? Mod Sn minus less than epsilon. Say Sn converges to S. What is the definition of limit? Mod Sn minus S less than epsilon. Then limit Sn equals to S. Both definitions are same. If Sn converges to a real number S means the limit of Sn is S. And Tn is any subsequence. We don't know is Tn is convergence or divergence. We don't know. But Sn is converges to the real number S. Then what is the formula here? Limit supremum of Sn into Tn equals to limit supremum of Sn into Tn. Two sequences we take here is equals to limit supremum of Sn into limit supremum of Tn. What we write here? Limit supremum of Sn into Tn as limit supremum of Sn into limit supremum of Tn. Already we know what is the limit of the Sn? S. So I write limit supremum of Sn in S in limit supremum of Sn place, and we have to find limit supremum of Tn here. Okay, is it clear? First I write limit supremum of Sn into limit supremum of Tn for limit supremum of Sn into Tn. Already we know the value of limit supremum of Sn. What is this? S. Then I write S into limit supremum of Tn. This is the one important point. Okay, next. See here, this is also another problem. Sn and Tn are the following sequences. There are two sequences. What are they? Sn and Tn. What are the elements in Sn? See here. Sn and Tn are the following sequences that repeat in cycle of 4. That means the elements of sequence are repeated. In cycle of 4 means first we write 4 numbers, then we repeat same 4 numbers, then we repeat same 4 numbers. This is called cycle of 4. Okay, see here 0 1 2 1. Again repeat 0 1 2 1. Again repeat 0 1 2 1. Again repeat 0 1 2 1. This is the cycle of 4. What are the elements of Sn is 0 1 2 1, 0 1 2 1, 0 1 2 1 like this. And what are the elements of Tn? This is also a cycle of 4. That means 2 1 1 0, 2 1 1 0, 2 1 1 0, 2 1 1 0 like this. These are the two sequences. Then find what we have to find here. A, B, C, D, E, F, G, 7 points. See here, first one is limit infimum of Sn plus limit infimum of Tn. Similarly, limit infimum of Sn, limit supremum of Tn. Next, limit supremum of Sn plus limit supremum of Tn. Next, limit supremum of Sn plus Tn. Next, limit infimum of Sn plus Tn. Limit supremum of Sn into limit infimum of Sn into Tn. These are the 7 problems. See here, first I write values of Sn and Tn. Solution. Sn is 0 1 2 1, 0 1 2 1, 0 1 2 1 like this. What is the infimum? 0 is the infimum of Sn. What is the supremum of Sn? 2 is the supremum of Sn. Therefore, limit infimum of Sn is 0. Limit supremum of Sn is 2. Similarly, what are the elements in Tn? 2 1 1 0, 2 1 1 0, 2 1 1 0. What is the infimum of T1? 0. What is the supremum of Tn? 2. Therefore, limit infimum of Tn is equal to 0. Limit supremum of Tn equals to 2. Next, first one is what we have to find here. Limit infimum of Sn. What is the limit infimum of Sn? 0. limit infimum of Tn. Limit infimum of Tn is 0. So I write 0 plus 0 equals to 0. A completed. Next B. Limit infimum of Sn. What is the limit infimum of Sn? 0. Limit supremum of Tn. What is it? 2. So 0 plus 2 is 2. Next C. Limit supremum of Sn. What is the limit supremum of Sn? 2. Next, limit supremum of Tn. What is the limit supremum of Tn? 2. Therefore, 2 plus 2 is the 4. Okay, is it very simple? Next, ABC after D. But instead of D, I find here E and F. After I find D. Okay, see what is E? Sn. What is the E bit? See here, what is the E bit? E means limit infimum of Sn plus Tn. First we find Sn plus Tn. After that we find infimum. Okay. First we have to find Sn plus Tn. What are the elements of Sn? 0 1 2 1 0 1 2 1 like this. What are the elements of Tn? 2 1 1 0 2 1 1 0 and so on. How can you add these two elements? Two sequences. See here, we add the first term of Sn with first term of Tn, that is 0 plus 2. After that I add second term of Sn with the second term of Tn, that means 1 plus 1. Similarly, third term with the third term. What is the third term here? 2. What is the third term in this? 1. Therefore 2 plus 1. Next 0 plus 1 plus 0. So what we get here? 2, 2, 3, 1. Next 2, 2, 3, 1. Next 2, 2, 3, 1 and so on. These are the elements of Sn plus T1. What we find here? See here. Limit infimum of Sn plus Tn. What are the elements of Sn plus Tn? 2, 2, 3, 1. What is the infimum of Sn plus Tn? Infimum means smallest value is the 1. Okay. Next, what is the value of limit supremum of Sn Tn? Supremum means maximum value. Maximum value is 3. So we write limit supremum of Sn plus Tn equals to 3. Okay. First for finding limit infimum of Sn plus Tn, first we find the value of Sn plus Tn. Sn plus Tn means we add the elements of the sequence Sn with elements of the Tn. How can we add? We add first element of Sn with first element of Tn, and we add second element of Sn with second element of Tn, like this. We get Sn plus Tn. After that we write infimum of Sn plus Tn and supremum of Sn plus Tn. Similarly, what is the D bit? Limit supremum of Sn into Tn. What is the D bit? Limit supremum of Sn into Tn. So first I find what value of Sn and Tn. Sn and Tn and also Tn into Sn, both are same. And Sn plus Tn and Tn plus Sn are also same. First I write elements of Sn. What are the elements? 2 1 1 0 2 1 1 0 and so on. And I write elements of Tn. What are they? 0 1 2 1 0 1 2 1, like this. How can you multiply? We multiply first element of Sn with first element of Tn. What are the first element of Sn? 2 into 0. Therefore 2 into 0. 2 into 0 first. What is the second element? 1 into 1. What is the third element? 1 into 2. What is the fourth element? 0 into 1, like this. What we get? 2 into 0. 0. Oh, sorry. This is 0. 1 into 1, 1. 2 into 1, 2. 0 into 1, 0. These are the elements of Sn into Tn. 0 1 2 0 0 1 2 0 0 1 2 0, like this. Now we write limit supremum of Sn into Tn. Supremum means maximum value. 2 is the maximum value. Similarly, what is limit infimum of Sn Tn? 0 is the minimum value of Sn into Tn. Okay. That's it.